follow what I say, okay? Like the things that I say usually it just revolves around it. So you have to be very sensitive to a lot of things going on in this question. First thing first, you should know that this is a ratio of 1 to root 3. So it means you can find the exact, you can actually find the exact argument for this one. This one is 1 to 1. So you can also find the exact argument and also the modulus. You get what I'm saying? So by considering the modulus argument of P0, so that's pretty okay. So first of all, you let this one inside here be a complex number. This is complex. So let it be, let's say, let A equals to minus 1 over root 3. This is easier, not so confusing. So I'll just bring this out first, right? Then B is equals to 1 minus I. Do that. Remember 1 to root 3, 1 to 1, 1 to root 3, 1 to 1, 1 to root 3, 1 to 1. You can find the exact argument, okay? The ratio is always like that one. It will never change one. The 1 to root 3, 10 million years ago, it was still 1 to root 3. 5,000 years ago, it's still 1 to root 3, 1 to 1. So it's the argument will be the same. So the argument, exact argument, okay? So this part here, so with this, right, I know that actually I could find my exact argument, which is actually just minus, oh, sorry, the wrong way. So it's here. This is minus 1 over root 3, and this is 1. Like that. Okay. This is 1. So actually, I think this is pi over 3. You check. Yeah, pi over 3. So this one here will be 2/3 pi. So hence argument of A is 2/3 pi. The modulus of A would just be, okay, the modulus, we can always find the exact value because it's Pythagoras theorem. It doesn't matter whether it's 1 or root 3 or 1 to 1. Any kind of ratio, you can always find the exact value. So 1 over 3 plus 1, which is 4, 3. So this will be 2 over root 3. Get it? This is important, huh? So rule number 1, remember 1 to 1 and 1 to root 3 ratios give exact argument. This one very important. Okay. Then obviously I think B is easier lah. B is really 1 and minus I. That's just my negative pi over 4. You don't need to draw it once you already know how to visualize it, the Argand diagram. But for some of you who struggle with the argument, I will just encourage you to just draw it. So this is minus pi over 4. Mod B is quite simple. It's actually root 2. Root 2. Okay, there you go. Settle this first. Now, once you've done that already, it's pretty simple because then you could actually just find P. Okay, P0 is equals to A5 over B4. So what you do is you want to find modulus of P0, right? Modulus of P0 is modulus A5 over B4. Okay, now bear in mind, if you are very fluent, you don't even need to let A and B be. You don't even need to let A and B be this. Okay, I'm letting A and B be the individual complex numbers just so to prove a point to you that 1 to 1 is the exact argument, 1 to root 3 is the exact argument. So you can just straight away solve it actually, but because no, you can do it, so I have to do it slowly. Okay, so this part here is mod 5. So this is root 2, 3. Okay, this one also, some of us would need some time to digest this. So 2 to the power of 5. Maybe I wrote this down properly. My Surface Pen is having a little problem. So this will be 2 and 4. Okay, realize that why I split it to 4, because 4 can insert the root 3 below. So this would be Just key in calculator. 2 root 3 about 4 times 2 over 4. Okay. Yeah. There you go. This is mod P. Then after that, I find argument P. Argument P conjugate is actually just argument A5 over B4 is actually just logarithm. Argument A is 2/3 pi. So this will be minus 2k pi. Keep at minusing 2. 1/3 pi. There you go. So argument P okay. What do we need to do next? Yeah. Modulus P conjugate. Modulus P is equals to 8 over 9 root 3. Okay, just like that. Cosine negative 60 will be half. Yeah, there you go.